Hello and welcome to my video 4.1 Creating Linear Equations. So this video is based off of the Math Makes Sense 9 textbook and is meant for my grade 9 math class. So the idea of this video is just to give an introduction to basically why equations are useful and being able to transfer a word problem into an equation. So if we look at this first one, it says how many people can fit for 30 tables side by side as shown below. So I'm making up this question. So basically each side that we see is going to be one person. So 1, 2, 3, 4, 5, 6, 7, 8. In this case we have 8. Now as we go, we can just imagine some smaller, like less tables and see what that looks like. So 1, 2, 3, 4, 5, 6. At this one, 1, 2, 3, 4. So here we have, let me do a different color. So if we have one table, 4 people, 2 tables, 6 people, 3 tables, 8 people. So we can see a pattern. So let's sometimes if we make a little chart, it helps us see the pattern. So number of tables, number of people. So first of all, if we had to draw out 30 tables, that would be just difficult. So we're not going to draw it out, and that's why having equations is useful. So if we now look at this, if we have one table, how many people? 4, as we have. 2 tables, 6 people. 3 tables, 8 people. Okay, so as we have more tables, we have more people, and it goes up by 2. We can hopefully see. So 4 to 6 is 2, 6 to 8 is 2. So we need to make an equation for this, and a really good introduction is my binomial video, so I will have that as well, so please look at that to what this equation will look like. But here is what we're going to do. We're going to call tables our x. That's our changing number. That's our, if we're thinking about science things, x is our manipulated variable. It's the thing that we can change. And in terms of science, the number of people is the thing that's responding. The thing that responds, it's like in science, a responding variable. So x and y. So if we have x number of tables, how many people can fit? That's our question. So we need to figure out what numbers and stuff we have to put around. So we can have a number here, and we can have plus a number here in order to make this work. So we need to think about this carefully. So first of all, we start with our base case. If we have one table, so if x is equal to 1, then y is equal to what? 4. That's what we said from this one, right? So what numbers do we have to have here and here in order to make that true? Remembering that if we have two numbers next to each other, it's like multiplying. This is sort of the question. When we look at it, we might be able to see from the pattern that we start off with 4, and every time we add a table, so if we add 1 here, it goes up by how much? By 2. So this is how much it goes up every time. That is our number that it changes by. So from here to here is 2. From here to here is 2, and etc. It's always going to be 2. So that's why this number here, I'm going to highlight in pink, this number is 2. It's because of these 2's. Okay. Now, if we look at the original number of people, in the case of one table, we have 4 people. So 2 isn't enough. 2 times 1 is 2. It's not quite enough. How much do we have to add? We have to add a 2 over here. So now, if we do this, 2 times 1 plus 2. 2 times 1 is 2. So 2 plus 2 is 4. And that's right. So that's how we're going to get our equation. So now that we have some numbers in here, our general equation is going to take these numbers and use them. So we have y equals 2 times x plus 2. And this is our equation for the number of people. That's the y. Let's go with red. This is the number of people and x, the number of tables. Okay, so the idea here is that as we add tables, the number of people goes up, and it goes up by 2. So this is how much it goes up by. So let's write this one down. The amount increase. And this one is usually our most basic case. Will tell us this one. So from base case. Now this is helpful, but it can be confusing because in this situation our base case didn't really work, because our base case is when tables are 0. But in this case, if we plug it in our equation, we'll have 2. So anyways, in this case it's kind of weird, but let's look at this next one. It might help us when we look at this next one. Okay? So this is a very important thing to look at. Okay? And if you're going to memorize something for this unit, that would be sort of my suggestion to you. That's sort of the most important way to look at it. The responding, maybe, responding, and manipulated. Okay, so this is kind of like science ideas, and math and science, especially at this point, start to really intersect a lot. Okay, coming down here, we're going to look at our next situation. I called Kelly's cabs. The cost of the ride is shown on the poster in the cab. So it says, cost of the ride is the fixed cost plus this much per kilometer. So if we're going to write an expression for A, write an expression or an equation or formula. Any of those words work. So maybe I'll write all those words here. Equation, formula. Any of those words work here. So if we're going to write one of those, we want to think about our cheapest situation and try out a couple different things. So we're going to go with, so thinking about how we did our chart before, this is going to be our x. So this is the manipulated variable. This is a thing that we can change. So in this case, it's how far we drive. So number of kilometers. Okay, this one is going to be our y, which is the cost. Okay, so if we go, let's say we go 0 kilometers, how much do we have to pay? Maybe I'll change that to a different color. If we go 0 kilometers, how much do we have to pay? Well, it says there's a fixed cost of this much, and this much per kilometer. So we don't have to pay for the number of kilometers because we've gone 0 kilometers, but we still have to pay the fixed cost. So $3.60. Okay, now, if we go 1 kilometer, we have to pay the fixed cost plus $1.50 for the 1 kilometer that we went. So it'd be 5.10. So if we think about this as we go, and we can do that over and over again, and each time it's only going to add 150. So 150, and to the next one, it's going to be 670, so it's adding another 150 over and over again. It's always going to add 150. So we're thinking about this in terms of an equation. Thinking back to how we did it before, we want to have y equals a box number, some number plus, x times x plus some other number. Okay, this is a binomial. So what we need is this, this is how much it's changing by. So we can take that from right over here, and then this one is our base case, which we can take from right over here. Okay, so if we do that, we have y equals $1.50 times x plus $3.60. Now, if it asks us any number, we can change that. Okay, so let's say it asks us C here for an 11-kilometer ride. Let's see if we can find that out without doing too much work. So for 11 kilometers, well, which one, where do we put 11? Well, if we can remember back here, x is the number of kilometers. So we put 1.5 times the number of kilometers, which in this case is 11, plus 360. Okay, so 11 times 1.5 is 11 plus 5.5, so 16.5, y equals 16.5 plus 3.6. Now we have 1920.10, and that is how much money it takes. $20.10. So if you follow down every step, it's just basically you make an equation, and this is basically what we're going to be doing for almost the entire unit. Basically, you make an equation, then you substitute your numbers in, which is like this here, and then you solve. You spend however much time to solve, and then you box the final answer. Okay? So if I write that beside, make equation, and remember that making equation is based off of base case, which I'll explain a little bit more of. It's the y-intercept, but we'll talk about that a little bit more. And over here, this is how much it changes. Sorry about that. So look at the base case and the y-intercept, which is the y-intercept for that one. And we look at the change every time for this one. So in this case, our change was the 1.5. So that is making the equation, which is the main part, and then you substitute where we put in the 11, and then solve or do your work or simplify. Any of those words work here. Simplify. And then box your answer. So I hope that this video helps you guys understand some of the basics of creating linear equations. Good luck!